Okay, these notes are molar mass and density. Okay, when using the gas laws, scientists sometimes need to figure out what kind of gas an unknown gas is. Two physical properties that are exclusive to each different type of gas is molar mass and density. We only need to know the mass of the sample of gas, the temperature and pressure that the gas is under, and the volume of the sample of gas in order to calculate both of these two. Okay, we can modify the ideal gas law equation to calculate molar mass and density. So PV equals nRT. Now, if you remember, when we keep dealing with moles and mass, in order to go from one to the other, you're either multiplying or dividing by molar mass. Well, if you have mass and you want moles, okay, you divide by molar mass. So basically, we can write that as N, which is the number of moles, is mass divided by molar mass. So it's a little m divided by a big M. So we're going to put that into our equation, little m over big molar mass, RT. Okay? Now a little trick, with math. When you have something on the bottom and something here, what you can do is you just replace them. You're just going to change places. The m's going to go here, m's going to go here, RT over PV. Okay, that is basically molar mass. It's how you calculate molar mass. So if you have the mass, you can have your gas constant, your temperature, your pressure, and your volume. You can find the molar mass. Once you find the molar mass of a sample, then you can figure out what it is. Now, after all is said and done, because I'm not going to show you how to move around the things anymore, there are three equations that come out of these modifications when you modify this. So let me move this up here. We have one of them, okay? The first one, of course, is the m equals little m RT over PV. Now, the next one basically uses density. And density, we know, is your mass divided by volume. So in this equation where mass and volume are, we're going to put a D here. So big M is D, the density. So we're going to replace the M and the V. I'm going to take that M and that V out. And this is my dirty P equation. See? Dirty P. So molar mass is also dirty P. Now, also, if you want to solve for D, and I'm not going to move it all around, but let's say we want D here, we would have to multiply by P and then divide by. So we'd have to move the P over there, so it's multiply by P and divide by RT. So it's dump dirt. Okay? So I'm not going to ask you to figure out how to rearrange the equations. You just have to know these three equations. I don't know if I have any of them on the sheet I gave you. I might have a couple of them, but if I don't, make sure you have them on there. Now, before we go any further, I want to make sure you guys know what each of these things is. So the big M here is your molar mass. Okay? And that's in grams per mole. That's the unit. The little m, so on the first equation, the little m is mass, which is in grams. Okay? And then D is density. And that has to be in grams per liter. And you should know the rest. R is the gas constant. Okay? And T is your temperature in Kelvin. P is pressure, and of course any of the units on that one, and B is volume, and that volume is in liters. Okay, so let's try an equation. Let's try an example. Okay, a sample of gas has a mass of 3.20 grams and occupies 2 liters at 17 degrees Celsius and 380 millimeters of mercury. What is the molar mass of the gas? Okay, since it's acting for the molar mass, it's going to be one of the two equations. So we either need a mass or a density. And I don't see a density, I only see a mass. So I'm going to go ahead and just write down what we have. And then we'll figure out the equation. So we're going to, oops, I guess it would help if I had my pen out. M equals 3.20 grams. Volume is 2.00 liters. Temperature is, now of course, We want our temperature in Kelvin. We never do anything in Celsius. So make sure you don't use Celsius in any of these equations. Okay, now we also have a pressure, which is 380 millimeters of mercury. Now, with all of these, we do need an R. So it all depends on our pressure, which is millimeters of mercury, so it's going to be 62.4. Okay, so we have all the stuff to go in this equation. How do I know? Well, I'm looking at everything I've got. It's the only equation that has M, V, T, P, and R. So I know to use that one. Okay, so it's going to be 3.20 times R, which is 62.4, times T, which is 290, all over P, which is 380, and V, which is 2.00. And the quick way to do this on the calculator is to multiply 3.20 times 62.4 times 290. Then hit the equals button. Then hit divide by 380. Hit equal button again. Then divide by 2. One fell swoop. You don't have to worry about writing down the two numbers. I mean, you can do it that way, but it's just, I like my way better because it's much easier. When you do that, you get 62.4 grams per mole. Okay, pretty easy, I hope. Let's try another one. Okay, what is the molar mass of a gas that has a density of 2.93 grams per liter at a pressure of 1 atm and a temperature of 22 degrees Celsius? Could this gas be chlorine? Well, before I go any further, chlorine gas is Cl2, which has a molar mass of 70.9 grams per mole. Remember, it's one of the Hofbrinkels, so I know it's Cl2 and not just Cl. So hopefully we get a molar mass close to 70.9. If we don't, then the answer would be no, and if we do, then yes, it could be chlorine gas. So let's go ahead and see what we've got here. We have a density of 2.93 grams per liters. We have a pressure of 1 atm. And we have a temperature of 22. Now, I'm going to add the 22 to 273, and I get 295. Now, once again, I need my R. I'm going to use, well, I'm giving ATM, so it's 0.0821. So my equation is this one. This is my dirty P equation. Okay, so M is 2.93 times 0.0821 times 295. Oops, I can't write today. Hey, it's late Sunday night. Okay, 295 all over 1.0. Okay, and when we do that, we get exactly 70.9 grams per mole. So the answer is yes. This could be Cl2. Ooh. Pen's going crazy tonight too. Cl2. Okay. Okay. So what is the density of carbon dioxide at STP? Well, since it's asking for density, it's the dump dirt equation. So dump dirt. So I'm going to have to make sure I fill in everything. Now, molar mass, it doesn't give you, there's no numbers in this problem. What the heck? Well, we can figure out all the numbers. Molar mass of carbon dioxide, which is CO2, is 44.01 grams per mole. How did I figure that out? Well, 1 C plus 2 O's. So I have my M, 44.01 grams per mole. Now, the P, it's at STP, so we're at 1 atmospheres, which means our R value is 0.0821. And guys, you don't have to use atmospheres. Now, on the quiz, please use atmospheres, but on your homework, you don't have to. Okay, you can put in whatever you want. If you do 101.3 kPa, just make sure you use the 8.341, as long as your, R value matches. Okay, and then T, of course, is 0 Celsius or 273 Kelvin. So we're going to put that in the equation. We get 44.01 times P, which is 1, all over R, 0821 and 273. Okay, and then when you do this, you get 1.96 grams per liter. So this is the density of CO2 at STP. Okay, if there's any questions, ask me tomorrow. We'll do a bunch of warm-ups so that you can get used to it, and then that way you can figure out which ones to do, and then you can do your homework, and we should be fine. So I guess I will see you guys tomorrow. Bye.